Alrighty, let's talk about proportions and direct variation. Proportions are not a new concept to you. Neither is direct variation, although you have never heard it called that before. In 8th grade, you did talk about things that had proportional relationships and what the constant of proportionality was. Direct variation is the same thing, just new name. But it's exactly the same thing. So it's not really new, but it has a new name, so it might feel new. This could be a long video because there is quite a bit to cover. So buckle up and let's go. Let's review solving proportions really quick. We have done this some, just to review so we make sure we know. This looks like a proportion to me. So to solve any proportion I'm given, I cross multiply. It gives me a new equation, or it gives me the equation, and then from that equation I can solve for the variable, in this case n. So we're going to cross multiply this direction first. So 2n times 8 is 16n. And then this direction, I have to do 5 times this whole thing. So I have 5 times the quantity, 3n minus 24. Well, I have to distribute over here. So I have 16n equals 15n minus 120. So I've got variables on both sides of the equal sign. So step 1 will be to subtract this 15n from each side, which gives me 1n equals negative 120. I've solved my equation. I know n equals 120. So to solve any proportion you're given, cross multiply. We're going to do the same thing with this next problem, but sometimes proportions are not given to you as a proportion. So here's what you're given. The ratio of the angles of a triangle is 2 to 3 to 4. So they give it to you in ratio format with the colons. You're asked to find the measure of the largest angle. Well, what this, I hope you all know, hope you all remember, is that all 3 angles of a triangle, when you add them up, equal 180. That's going to be important. What this means is that if I were going to label the angles in my triangle, this one's 2, this one's 3, and this one's 4. I do realize that when you add those 3 numbers up, they do not equal 180, but that's what that ratio represents, okay? 4 would be your largest angle. We are going to add these all up, though, and find out what they do equal. So 2 plus 3 is 7. Wow, 2 plus 3 is 5. And 5 plus 4 is 9. It's been a long day, guys. So 2 plus 3 is 5, and 5 plus 4 is 9. So my total in this triangle, given the ratio they've given me, is going to be 9. And my largest angle in this triangle, given the ratio, is 4. So the largest angle out of 9 total is equal to whatever the largest angle is if I have 180 total, because a real triangle, when I actually plug in angles, equals 180 degrees, not 9. But that's where I got the 9 from. So then to solve this, I'm just going to cross multiply. 9 times x is 9x, and then 4 times 180 is 720. And so then I'll divide by 9 on both sides to get x, which will tell me what the largest angle in my triangle will be. And it is 80 degrees. And so if you are just given the ratio, you're going to use that ratio to your advantage by labeling a triangle with what you're given, and then use what you know about a triangle to solve the proportion. Okay? Alrighty. So let's talk about dimensional analysis. Dimensional analysis, that's very hard to say. Dimensional analysis is important because we use it to make conversions. We use it to convert simple things like how many seconds are in a day, or how many seconds are in a year, or how many centimeters are in a meter, or how many miles per hour kind of things. Any kind of conversion, dimensional analysis is very useful for. We're going to do one dimensional analysis problem together. You will see some of these on your homework. You will also probably see some on your test and probably the benchmark. This also is very useful in science, because when you get to science class, you have to convert, and convert a lot. So dimensional analysis you have probably seen before, but we use it to make conversions. So let's go with what we know. You're throwing a pizza party for 15 people and figure that each person might eat 4 slices of pizza. You call up the pizza place and learn that each pizza is $14.78, and they're going to cut each pizza into 12 slices. How much is the pizza going to cost you? We want to know how much total the pizza is going to cost. So let's start with what we know. Okay, we have 15 people at your one party. That's what we know so far. And I'm going to write everything in this dimensional analysis as a ratio. And all of the ratios must cancel one another out. So my next thing must have people on the bottom so that these units cancel out these units. Okay? And it's really not people, it's going to be person. One person is going to have 4 slices. That's what it says. So 4 slices for one person. So now your persons cancel. So this part of my dimensional analysis needs to have slices on the bottom. Well, the next thing we know about slices is that there are 12 slices for one pizza. Wow. So now my slices cancel. But now I need pizza to be on the bottom. Okay. And so what I know is that each pizza is $14.78. So it's $14.78 for one pizza. So now my pizzas cancel. Now I do know that I have 2 different units left. I have dollars per party, which is what I want to know. How many dollars is it going to cost me for my one party? All of my other units have cross-canceled each other out. What is remaining are just numbers, and the numbers are going to tell me how to solve this problem. So I'm going to have all my numerator. I have 15 times 4 times 1 times 1478. That's across the numerator. And then in the denominator, I have 1 times 12 times 1. Well, all the ones take care of each other, so let's multiply across the top. So I have 15 times 4 times 1, which doesn't change anything, times 1478, which gives me 886.8. And that is divided by 1 times 12 times 1, which is 12. And if I divide that by 12, what I get is that it is $73.90 per party for the pizza. So the pizza is going to cost me $73.90 if all of these 15 people eat 4 slices and each pizza is cut into 12 slices at $14.78 a piece. But the reason for the dimensional analysis is to convert. And in this case, I was converting the number of slices of pizza and the number of people to the cost for the party, how much I'm going to have to spend on pizza. So there is a dimensional analysis example. We will have some more when you come to class. Let's talk about direct variation. What is direct variation? Well, a direct variation problem, okay, looks like this. They are always written in the form y equals kx. And I know you have seen this before. It was an 8th grade concept. And in 8th grade, this k was called the constant of proportionality. In Algebra 1, k is called the constant of variation. So k is always going to be a number because it is a constant. And we're going to probably most likely have to come up with what that number is on our own. But k is the constant of variation. Y and x will remain variables until I am given more information. K is the constant of variation. You will notice that direct variation equation is only multiplication. There is no addition or subtraction going on. That's going to be important. So we're going to practice recognizing it really quick. So first we're going to identify if each of these is an example of direct variation, and if so, we're going to identify the constant of variation. So what I'm asking you is, can it be written or is it written in this form? Y equals kx. So look at the first one. Y equals 4x. Well, I think this looks a whole lot like that. Y equals kx. Well, so I'm going to say yes, this is a direct variation. And in this direct variation, k equals 4. Now, number 2 over here does not look like this right now. What we need to see is if it can be rewritten, and the reason we did literal equations a couple days ago is because now we're going to rewrite. Right here, y is by itself. So right here, I want to get y by itself. That's the only way I can determine if it's a direct variation. So I'm going to subtract this 2x to cancel over here, but I also have to subtract it over here. So I end up with y equals 10 minus 2x. Now, does this look like this? No, it does not. And the reason it does not is because of this 10 minus. This subtraction part, you don't see in this, so it cannot be a part of it. So this is not an example of a direct variation. So let's practice. You're told that y varies directly with x, and when y is 84, when x is 16, first of all, they ask you to find the constant of variation. So here's how this works. Direct variation formula is y equals kx. Well, given the information in the problem, I know that y is 84 and x is 16. So I'm going to plug those numbers in. Well, if I want to get k by itself, I simply divide by 16 on both sides. So I get that k equals 5.25. And we're going to go ahead and divide, make that a decimal. And it's fine, because it's a nice decimal, it doesn't repeat. So my constant of variation is 5.25. Part B says write a direct variation equation to represent this situation. Well, to write the direct variation equation, we go back to here. Y equals k, which is 5.25 x. That's what the direct variation equation looks like. To find the constant of variation, I had to use the information given in order to do that. So that's what direct variation looks like. So let's do one more. The amount of chlorine C needed for a swimming pool varies directly with the amount of water W needed to fill the pool. So C varies with W. That's going to be important. If 16 units of chlorine are needed for every 1,250 gallons of water, write an equation that represents this situation. Well, 16 units of chlorine for 1,250 units of water. I need an equation. Well, they're basically asking you to do what we just did because you're told it's direct variation. Well, if I replace C and W with Y, in the statement here, Y varies directly with X, C varies directly with W. So I'm going to change colors here so that this does not get too confusing. Y varies directly with X. That's how those statements are. You don't ever hear somebody say X varies directly with Y unless that's the way they want the variables to follow. Okay? But Y varies directly with X. That means that Y is 16 when X is 1,250. And then, so in order for me to write an equation, I've first got to have what K equals. So I'm going to divide by 1,250. And yes, this means I'm going to get a decimal. And I should, because the amount of chlorine you need for water, you don't need a whole bunch per gallon, but here's what you're told. 0.0128 equals K. So your constant of variation is 0.0128. And so your equation for this looks like this. And if we wanted to replace it with the information we're given, chlorine equals 0.0128 times the gallons of water. So that would tell you how much chlorine you need for per gallon of water. That would give you the information you needed. So there is the equation. That's direct variation. That's dimensional analysis, proportions, all wrapped up in a nutshell. And we're going to practice some more tomorrow. So if you still have questions, feel free to ask then, and I will see you then.